Welcome to another tutorial on MATLAB. In this particular tutorial, we are looking into the plant modeling approach using MATLAB. In the previous videos, we have seen the Simulink implementation of the same, but in this video, we will be looking into how we can implement the same in MATLAB environment, which is the scripting environment. So to develop the plant model, we need to have a system or a plant through which we can understand the system, and we will be developing the plant model in MATLAB environment, which is the scripted environment. To get the basic understanding of the same, we have a two mass damper system where M1 and M2 are the two masses, and the K1 and K2 are the two springs which are attached to these masses, and D1 and D2 are the two dampers that are attached to these masses. So when we will be pulling this particular block, which is the M1 mass, there will be an oscillations that will be generated in the entire system, and that oscillation will change the displacement of the springs and the displacement of the masses. So here we have x2 as the displacement of the mass m2 and x1 as the displacement of the mass m1. To understand the entire system, we need to analyze the system in a component level. So we have two components here, m1 and m2, which are the two masses, and they have a displacement of x1 and x2. Let's see how it looks like. So we have two forces which are pulling up for the mass m1. So first is the spring force and second is the damping force. The spring force is more related to displacement, and the damping force is related to the velocity of the entire system. So here there is a relative velocity which is obtained by subtracting x1 minus x2, because x2 is the motion that is executed by mass m2. So based on that, we need to calculate the spring forces. So here we have the spring force, which is spring constant multiplied by the displacement divisible by the mass m1. So this is the first term in the system equation. Then the second term in the system equation is the damping force related part, which is this part. So this is related to the damping force, and this is related to the spring force. And this term here is not written correctly. This is F by M1, which you can see here. Later on we will see this also. So this is the system equation for the mass M1. So this is for M1, and M1 is more related to X1. So this is the dynamics related to X1, and this is the acceleration for mass M1. Similar way, we can formulate the equation for the mass M2, which is related to the displacement x2, and here the forces acting is the spring 2 force and damper 2 force, spring 1 force and damper 2 force. So these forces we need to subtract, and then we need to make it equilibrium. So you can see here, this is the spring force and this is the damping force that we have got from the system equations, and we can ignore this term. So this term is not there. So yeah, so here we have now, this is the equation for acceleration of mass m2. So acceleration of mass m2. Now to develop a script based plant model, we need to have a state space model. So state space model is a model which represents a matrix formatted equation which is of kind dx by dt, which is the change in dynamics, equal to a into x, which is the states, plus bu. So here b is the input matrix, a is the transition matrix, and x is the states, and u is the input. So based on different inputs, the states of the, like this is the previous state multiplied with the new state, like multiplied with the transition matrix, and you will get a new state with the relevant inputs. So this is how a basic state space equation looks like. So it is similar to this one. So this is the dx by dt, and this is a, and this is x, and this is the matrix b, and this is the input u. So as you can see here, this is the input, so that's why we have this input matrix with input u. So this represents the entire state space model for the mass damper system, which is a double mass damper system. And here this is the displacement of mass 1, this is the velocity for the mass 1, and this is the displacement for mass 2, and this is the velocity for mass. So that's how we can get at every time instant the displacement and velocity, and as we are taking the derivative, we will be also getting the acceleration of the entire system. So basically at every moment of time we will be getting in our simulation displacement, velocity and acceleration. So using this plant model equation, which is the state space equation, we will be creating the next script, which will be coming in the next video, and there we will be creating this entire script, which will be simulating over around 10 seconds of the entire simulation time, and we will be seeing how the response looks like in this particular double mass damper system. In case you are liking the channel, please consider subscribing. In case you have any query or comment, please share it in the comment box. It will help us to improve your experience of learning MATLAB, as well as you can ask your doubts in the comment section. We will try to clarify it, and it will also help you to get better understanding on the concept that we are discussing in this channel. So happy learning MATLAB. Have a good day. Thank you.